today we want to present the remaining parts of our topic we started the other time, that was acids and bases. And today is going to be on salt, and it's going to be latif as usual. To a layman, salt is just what our mothers used to cook at home. But to a science savvy, salt is not meaning the same way as it means to non-science inclined people. So because of that, we need to understand what is meant by salt and to have an in-depth knowledge about its preparation. We have different types. Then there are many other things that can be discussed under salt, and also some uses of some salt we need to be delved into. So the learning objective for me after this lesson is going to be on defining salt, what it means scientifically, and to identify various methods of their preparations. The various types of salt needs to be examined. Then hydrolysis, a very important aspect of salt, will be treated. Then the equation, that means hydrolysis equation, we need to be considered also. Then the property of the resulting solution after hydrolysis. Then finally we go to understanding some uses of some salt. So as a matter of introduction, in scientific balance, salts are substances that have positively charged metallic ion, like sodium ion, like calcium ion, like potassium ion, like ammonium ion, like even lithium ion, like many other positive ions. In that same compound, we have a positive positively charged metallic ion. Then to balance it, we need a negatively charged acidic ion. So the acidic ion can be sulfate, can be sulfite, can be nitrate, can be chloride, can be carbonate, can be anything. So the combination of these two types of ion make up what is called salt. And a wider view, salt are mostly prepared from neutralization reaction between acid and base. We have talked about that before. So this is an example of neutralization reaction that we just talked about now. Acid reacting with a base to form salt and water. It's a very important topic. It's a very important aspect, very important reaction in chemistry, because it happens almost every time. That is in chemistry practical, O-level chemistry practical, or in other reactions. Neutralization reaction is very, very important. So, in view of that, constitutes a very broad way of preparing salts, although soluble salts. So from there we go to what are the types of salt. We have many types of salt. Number one is the normal salt. As the name implies, something is normal. It doesn't have excess of anything, just balanced. So a normal salt compound formed when all the hydrogen ions of an acid have been replaced by metal ions or by ammonium ion. What we are seeing is this. In acid, for example, this one. In acid, we have hydrogen. In base, we have the metal. So if there is a reaction between acid and base now, or acid and maybe on metal or a carbonate or any other compound apart from the acid, such compound must contain a metal. If the metal now replaces all the hydrogen in the acid. Then the result is the normal salt. This is what we have here in the neutralization reaction. We have one atom of hydrogen, we have one atom of sodium, that is a metal. This one atom now replacing one atom of hydrogen, so it forms a normal salt. You can see in this salt we don't have excess hydrogen, we don't have excess hydrogen, so it is a normal salt. So a normal salt can be water soluble or not. It depends on the way we prepare it. So as a matter of guiding, these 4 elected groups of compounds are soluble in water. As your nitrate, you can be asked to provide examples of soluble salts. You can provide all nitrates, calcium nitrate, sodium nitrate, ammonium nitrate, element nitrate, magnesium nitrate, all are soluble in cold water. Another group, a large group of soluble salt are sodium, potassium, and ammonium salt. All sodium, potassium, and ammonium salt are very soluble in water. All common one. Alkalies are also soluble except lead, silver, and mercury. Then we have all solvates except lead, barium, calcium. So it means sodium sulfate is soluble, potassium sulfate is soluble, potassium chloride is soluble, sodium chloride is soluble. There are all this group of compounds. I'm not saying they're limited to this one, but experience has shown that all these large groups, mean nitrates, one group, sodium, potassium, and ammonium, another group, and this other, so the other 2 separate groups, they are very soluble in cold water. So this is an example of normal salt. I've just said this in the Hydrolysis reaction, acid and base. To form this, we can have another reaction to form this, have anything to form this, have anything to form this. Our aim is just to make sure that in our salt we don't have hydrogen, we don't have hydroxide. As those are examples of normal salt. Another broad example of salt, type of salt, is the acidic salt. That is just when the replaceable hydrogen ions in an acid are not completely replaced. It means if we have this another reaction between acid and base again, the number of metal, the amount of metal is not equal, meaning it's less than the total number of hydrogen ions that can be replaced. We have one sodium here, wants to replace 2 hydrogen. To do that, we need 2 sodium metal, but here we have only 1 sodium. So 1 sodium now replaces 1 of the hydrogens. So we have imbalance of 1 hydrogen. So in this salt now, we have a positively charged potassium ion and negatively charged sulfate radical. So positively charged sodium ion and negatively charged sulfate radical. Then again we still have hydrogen in excess. So this hydrogen is present in this constituent what is called acidic salt. And we have water as usual. So the underlying compound is the acidic salt because it contains hydrogen. Another group is the basic salt. This is when base is more than acid now. So instead of as we have hydrogen here, then we have hydrogen here. That is for the base. That is why we call it basic salt. That one is called double salt. Double salt is just double when you have double of what should be normal salt. You have double of it. Like we have potassium salt, potassium sulfate, and we have ammonium sulfate. When I have the 2 of them mixed together, we have 2 positively charged metallic ion. Then we have one acidic ion. So in example of something like that called double salt. Then we have what is called a complex salt. What is called a complex salt? A complex salt is just a complex that is formed from what is called a coordinate covalent compound. We have talked about that before. In that compound, we have negatively charged ion, more negatively charged ion, and now surround one central metallic ion. That central metallic ion is called a ligand. That ligand is the only positively charged ion there. Then all other It might be a radical, like graphene cyanide. It might be another compound. Just make sure they are negative. When we have something like that, it's called a complex salt. Don't forget our basic definition of salt. It must contain positively charged metallic ion and negatively charged acidic ion. So how do we prepare all this salt? We have known the types of salt: normal, the acidic, the basic, complex, and double. So how do we prepare them? So the method to which salts have been prepared depends on the property of salt. I mean their solubility property. Are they soluble or not? Because some some methods are specifically used for preparing soluble salt. Some are for general preparation. Let's not take them one after the other. If we have reaction with acid and alkali, that is alkali is a soluble base. That is neutralizing reaction. So this method is generally used for preparing salt that are very reactive metal. A reactive metal like sodium, like potassium, like calcium, like magnesium. So if we have the base of all those reactive metal, so we now react them with an acid, there's going to be formation of salt. That salt will contain a very reactive metal. Like here now we have sodium. So we have sodium salt. If we had potassium here, we will have had potassium salt. If it were calcium salt base in here, it's going to be calcium salt. That's what we are saying. A very reactive metal of a base is produced in a salt. So apart from using hydroxyl as a base, we can use oxide as our base. We should not forget the Arrhenius definition of a base. It is not every time that we have hydroxide if you have a reaction with an acid. So if you have an acid, then the other compound that is present acts as a base. So in this case now, copper oxide is now acting as a base. This is an acid. So if we have these two reactions, we're going to produce copper salt. We have water. So metal oxide is used in this case as a source of base, and metal is still used to produce a soluble base. So sodium chloride is a soluble base. Copper sulfate is a soluble base. We can see it falls among those categories of salt that we said they are soluble in cold water. Another preparation is the acid plus metal. If we have only metal, then with an acid. So this is a very good method, but it is being used when we want to produce a salt that contains a moderately reactive metal. The first one we talked about was preparation of a very highly reactive metal, but this one is for moderately reactive metal. So the metals are usually used in this method. They're called MAZIT, that is magnesium, aluminium, zinc, iron, and tin. So you can form any salt you like with these 5 compounds. They are moderately reactive. You can put zinc in this case, react with nitrate, or you can react with sulfate, you can react with chloride. So you form salt and the hydrogen. Because all these metals, they are both hydrogen in the electrochemical series. So if there is a reaction between the two of them like this, it's going to be replacement. So this equation is not balanced. We have talked about balance in the equation. Balance is between 2 in this case. So if you put 2 here, it's balanced. Sorry. We need to put 2 here, and we put it 2 here already. So there's going to be replacement of this hydrogen with magnesium. Magnesium has 2 positive charges. So if we put them here, we are going to be a replacement of 2 hydrogen. So this is the hydrogen. We have our normal salt as usual. We can have acid plus carbonate. Carbonate salt are also used to produce another salt. This can be used with any metal carbonate and acid. When the salt produces soluble, if you want to produce a soluble salt, you can have another salt. But let's say we don't need that salt. We want to produce a salt of a compound. We need, like in this case now, we need the nitrate salt of copper. But what is available is nitrate of an acid and carbonate of copper. So we can react the two together to form nitrate of copper that we need. It's also a soluble salt because all nitrate salt are soluble, so it's soluble salt. This one is not soluble. We want to produce a soluble salt. So we add these two together to form a soluble salt. Then there is going to be a formation of a gas, that is CO2. This precipitation reaction, now that is the next one, is specifically used to produce insoluble salt, meaning salts that are not soluble in water. This is done by mixing two soluble salts together. Then we're going to produce one soluble and one insoluble salt. That insoluble salt is going to form a precipitate. The precipitate is filtered off. That is what we need. That is the residue that we need. The soluble salt will go with the water. That's what we don't need. So this barium chloride now is a soluble salt. We react it with a solution of sodium sulfate. It's going to be a reaction that's going to be the exchange of ions and radicals. And we have barium sulfate and sodium chloride. Sodium chloride is soluble salt. We use it in stone. And barium sulfate is not soluble. That is what we want to produce. So after the reaction, there's going to be a mixture of these two. Then we filter them off. We have only this one goes with the water. This method is what is also called double decomposition reaction. We call it precipitation because it precipitates this. Double decomposition means you want to decompose these two salts, then form another salt. That is it. I think that is all about preparation of salt. Another concept we are going to visit is hydrolysis. So what is called hydrolysis? Hydrolysis means addition of water to a substance. To hydrolyze something that you put water into it. So the salt that we are hydrolyzing now, you add water to it, and there's going to be dissociation into its constituent. So if there's dissociation into its constituent, there's going to be a resulting solution in this case now. Can be neutral, can be acidic, can be base, depending on the constituent of the initial salt that we hydrolyzed. Example is this sodium chloride now. If we hydrolyze this sodium chloride, we're going to form sodium hydroxide and hydrochloric acid. Those are the components that form this salt initially. So in this case now, the solution is going to contain sodium hydroxide and hydrochloric acid. Sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. Strong versus strong is going to produce a neutral solution. That is the property of the resulting solution. I don't mean there is imbalance now. I mean in terms of strength of the acid or a base. If the base is stronger than the acid, then we have a basic solution. And we have acidic solution vice versa. That is if the acid is stronger than the base. So if the two of them are weak, we have neutral also. So this table provides the idea of the resulting solution after hydrolysis. So if we have a strong acid versus a weak base, so we expect acidic solution because acid is strong. If we have a strong base, we have a basic solution. If the two of them are strong, we have neutral. If the two of them are weak, we have neutral. All these are examples of what we are going to get after hydrolysis. It's going to give us a glimpse of how to predict, because it is not by magic, it's just by dividing it by dissociation of the compounds, I mean the salts, after water has been added. So these are uses of salt, like ammonium chloride is used in touch batteries. Everybody uses torch at home. Ammonium nitrate is a very good source of fertilizers. We use calcium carbonate in extraction of iron and glass making. That calcium carbonate is what gives glass that transparent color, and it makes it to solidify. Magnesium sulfate is used in medicine. Potassium nitrate is used in fertilizer. Silver bromide is a very reactive compound, and that's why they use it in photography. So there are many examples of salt. These are just few of them. So before we go, let us have a review of what we have talked about. Salt are compound with positively charged metallic ion and negatively charged acidic ion. It can be radical, like SO4 minus. That is a radical. If it's an ion, that is chloride. Just one compound, that's one element. There are many types of salt. This is normal, insoluble salt. Okay. The other concept is hydrolysis that we just talked about now. Hydrolysis of salt is the addition of water to produce a solution of that constituent bases. It can be ammonia, and acid, metal. So those are just what we need to do for today. But before we go, let us have some exercises to demonstrate what we have learned. Each of these compounds is a normal salt. As I have said, you just need to look at all the salt. Normal salt will not contain anything, either acid or base. So all other compounds contain hydrogen. That is an indication of acid. It's only option A that does not contain that. So because of that, that compound is a normal salt. Aluminium hydroxide is used in the industry as it does. What they use aluminum hydroxide in the industry is, if you have a dye, if you have a fabric, you want to make sure the dye sticks to the fabric, then they use aluminum hydroxide to make it stick to that fabric. So in that case, it is not a dye itself, it is not a dispersant, it is not a salt, so it is a mordant. A mordant is what fixes dye to that fabric, make it form that pattern that is forming. Phenolphthalein acidic solution is what? So we have talked about that in the last class, that is colorless. You can see the basicity of ethanoic acid, C3COH, is what? Is monobasic. Option A. Specifically talk about this. The color of methyl orange in alkaline solution is what? Methyl orange in alkaline solution is what? Option A, that is yellow, because it was pink in acid. So if you add a base to it, there's going to be color change. What is the pH of 0.001 mole per dm solution of sodium hydroxide? So this question is tricky. We have to find the pH of a solution, but that compound is a basic compound. So what we need to get first is to get the pOH. We need the formula to calculate the pOH. Then we now subtract the pOH from 14 to get the pH. That is option 1. That is what I did here. Find the pOH. After finding the pOH, you get 3. Now subtract the 3, that is pOH. Now inflate will that pOH and pH is equal to 14. So if you subtract the pOH from 14, we get P, that is option D, 11. So the exercise, the assignment for you now is to use another formula. In the last class, I used the concentration of hydrogen and the concentration of hydroxide. If you multiply the two of them together, you are going to get 1 times 10 to the power of minus 14. So in the case of, in place of hydroxide ion concentration, put 0.001 and you get the hydrogen ion concentration. Then now find the pH. Find the pOH again. If you find the pH, you are going to get 11 straight away without need to do some subtraction. Although this approach is the easiest. I can say it. It says it depends on you. I can do anyone I like. So thank you for listening. Have a blessed day ahead. Next video is going to be on chemical reaction with sample question and solutions. Thank you. God bless you.